Much. So I will not show much data. I will rather present the concept of this European project that is called ADTKD-net. And this project goes back to a call that was launched by the European Union in 2023 with the title Natural History Studies Addressing Unmet Needs in Rare Diseases. So it we thought at the time that it's actually very much fitting what we need in ADTKD. And we thought it's exactly the right step to better characterize the natural histories in this disease entity. So we grouped together with lots of partners. Some of you are in the audience, and we were happy to get funded. And this funding started in June last year and is planned for 3 years. But the project, of course, as a total, is meant to be to last much longer and meant to be a sustainable one. So I will just briefly start out with natural histories and why this is so important. And this is just a slide from another field of medicine, lung disease, chronic lung disease, obstructive pulmonary disease. And you see here that when you want to characterize and you want to select patients for their highest risk, you really need to characterize the natural histories. So who is going to end up in a premature death and who is to end up in almost subnormal or supranormal lung function. So this applies to every field. And for us nephrologists, we're very much familiar with the natural histories in ADPKD. And I think Joost has already showed that in his biomarker presentation that we can learn a lot from ADPKD when we're now dealing with ADTKD. So these EGFR predictions you're all familiar with come from the Mayo imaging classes, which was basically an observation based on natural histories of total kidney volume, and which could then predict how fast kidney function is going to decline in the future. For ADTKD, this is even more important because there may be clinical trials on the horizon. We're all hoping for clinical trials, and you know that there have been lots of efforts from the group of Anna Greca in Boston with regarding TIMID receptors, but also what Olivier Deves just showed, gene therapy approaches like ASOs and base editing. And we're all hoping that in the near future, there's going to be phase 1, 2 trials. And to be ready for that, we need to know who is actually going to need treatment in a prioritized fashion. So who is going to progress fast and who is going to progress rather slowly. So we grouped together with a lot of players in the field, mainly 6 partners that are that received funding, that were eligible for funding. You know, in these EU projects, there's always certain countries that are eligible by their national funding agencies. So we had 6 funded partners and a lot of collaborators named down here. We at Charité are the coordinating center, but then there is Michael Wiesner at Erlangen, there's Olivier Deves based at Zurich, but also being involved with Eric Orlinger from Brussels. And then there is, of course, Necker with Corinne Antignac, Bertrand, Laurence Edé, and Guillaume. And we have the Irish Center led by Peter Conlon as a funded partner, and we have Rosa Torra and Elisabeth Ars from Fondation Pour. And these collaborators pretty much represent national ADTKD players with their national cohorts. I will show you that in a minute. We also included a patient advocacy organization that is called ADTKD Vision Cure. It's the only European ADTKD patient organization led by Christian Schleitler. And then we also included the non-European partners, notably Tony Blair. You may all know he has been very active in building an North American registry called Wake Forest Registry. But also including patients worldwide with ADTKD. So the goal basically is really to team up with a multidisciplinary team. So there's not only nephrologists included, but also geneticists and bioinformaticians and data science experts. This spanning across more than 10 countries, and we want to share patient data, do biobanking, and then in the end design protocols for clinical trials. And the goal, of course, is to join forces to improve diagnostics and pave the way for targeted therapies. In the proposal, we had these four main aims: capturing natural causes in terms of kidney-related and non-kidney-related outcomes, better define the genetic and environmental factors that may account for observed disease variability, and then identify predictive biomarkers, ideally, that account for disease viability and could guide us in a way to select patients. And the overall goal, I already told you, to achieve trial readiness. So in this first phase that we, like after a year now, we build up a new sub-registry that is um, based on the ERC-REC, on the European Rare Kidney Network Registry. And if you're familiar with the structure in ERC-REC, there is a core registry, but you can basically, beyond that core registry, you can design sub-registries for specific entities. And in this case, we thought this is worth doing. The ERC-REC infrastructure is, yeah, kind of ideal because you don't have to come up with a new registry that is data protected and that is already functioning. And in the sub-registry design, you can basically still customize whatever data you want to collect. So this registry setup was the first step that we achieved in the first year. And then the enrollment phase, this is where we are now. And we are aiming for about 1,000 cases. I will explain that in a second. First of all, by including retrospectively patients that have already been entered into ERG-REC, and also a prospective enrollment over the next years. And then the goal for the upcoming time is to not only collect clinical data, but also collect biomaterials, blood, urine, kidney biopsy samples, and imaging. And then in a way to provide a resource for biobanking, for biomarker research, so that biomarkers, and biomarkers can be fluid derived from urine, from blood, but they could also be imaging biomarkers that tell us something about the natural cause and the risk of renal deterioration. And then in the end, the kind of the vision that we came up with is to integrate all these different facets and levels into an integrative risk stratification model, which is, of course, very ambitious. So the inclusion criteria is genetically confirmed ADTKD, the main entities, UMAT and MAG1, the rarer entities, REN and HNF1 beta, minor genes that I spelled out here. This is, of course, a matter of debate, as you heard with DNA-JB11. But in the end, we also decided to allow or to enable inclusion of NOS, not otherwise specified ADTKD cases. So where clinicians really think this is fitting an ADTKD clinical presentation, but it's not genetically explained by any of the existing disease genes. For HNF1 beta, as you all know, this is a matter of ongoing debate. What do we actually mean with ADTKD HNF1 beta? So as a consensus, we said we want to collect non-congenital cases, no non-CACUT cases. Bertrand put it nicely, they should have two kidneys, they should not have renal agenesis. So non-CACUT basically means preferentially adult onset, more kind of a tubulointerstitial disease pattern, non-ADPKD-like, non-cystic could be single cysts, but non ADPKD presentation, and the clinical criteria that were defined in the 2015 original paper should match the inclusion. So this is again from the proposal where the collaborating and partner centers provided their numbers of existing ADTKD patients, and this is where the 1,100 patients in total comes from. And this is basically existing patients that are still spread out in some kind of national or regional registries. So this whole project is aiming to combine national cohorts and regional cohorts to come up with an European infrastructure. So we know that these patients are diagnosed, they're out there, but they're not collected in a harmonized or centralized way. This is a slide from the EUCREC core registry. I told you that there is a core registry in EUCREC that is collecting basic clinical data. And already now there is 130 patients with ADTKD UMOD and ADTKD MAC1. Not a huge number, but this is, of course, the first group of patients that will be automatically transferred into the sub-registry. And for HNF1 beta, this is nicely illustrating the problem of definition. There is a lot of patients coming from the pediatric side, as you see here in green, and they're probably rather CACUT presentations. So we need to find out in a stringent way who is actually going to go into the ADTKD sub-registry in this group. The registry, as I told you, is one of, I think, 8 existing sub-registries right now. And it's the first sub-registry in EUCREC that is coming from the autosomal dominant structural disorders. And it was just launched in March, is now open for 3 to 4 months. This is how it looks like. You can basically, that's the clinical inclusion criteria, and then the genetic inclusion criteria you can choose from these 4 groups or 5 groups when you include NOS. And then you will be asked to enter the disease causing variant and the genetic methodology. And of course, for MAC1, this is including the MAC1 sequencing techniques like snapshot or VN-typer. One special feature that is distinct to our registry, and we think this is a very important one, is that it allows to put in every creatinine value you have from a patient from the past. So you can basically, without having a full visit of the patient, you can just enter creatinine values with the methodology. And this was very important to us in the registry design because we want to create eGFR slopes. And eGFR slopes, of course, are important to actually come up with a natural cause of kidney function. Creatinine values, the more the better, and the more precise to really describe what is the natural history of kidney function decline. As I told you, for the group of any NOS non-specific cases, we wanted to be inclusive and rather include patients and clinicians or motivate patients and clinicians to have their cases entered into the registry. And that's why we came up with a consensus definition. So NOS would mean no disease-causing variant in any of the major ADTKD genes. Of course, also no explanatory variant in the minor genes. And ideally, a broad CKD panel should have been done previously. Family history should be positive with 2 affected generations of impaired kidney function. And the supportive clinical criteria are listed here: adult onset disease, autosomal dominant, pedigree, progressive decline in kidney function, bland urinary sediment, and only mild proteinuria. there are cases with quite some proteinuria, but any of these clinical criteria is not an exclusion, but it's just guiding clinicians when they enter their patients that they should be aware of these clinical criteria. It's lots of things are more exclusion of other diagnoses, like clinical exclusion of ADPKD. So this is the current status of the sub-registry entries, which is yeah, not a lot for now, but it's only open for 3 months. So 119 patients have been entered in the sub-registry, mainly from our partners in Dublin, but also second is Paris already. So that's very good. And then we have these about 130 patients from the core registry that are where the data is there already. So we're moving along, but we're still hoping to have now an exponential growth in the registry because we really need to have a substantial number of patients in there to have a good statistical resource. Along with the clinical data collection, I already told you biobanking is something that we started. There was a discussion on how to design the biobanking, and of course, this is always a difficult decision. Do we allow individual protocols, or do we try to have it harmonized, standardized in a way across all centers? We came up with a protocol that was pretty successful in the German chronic kidney disease study. So we basically took this protocol and suggested that to all partners. This is quite extensive, I have to admit. So this is collecting serum, EDTA plasma, urine, centrifugaged and uncentrifugaged. And it also collects PAX-gene tubes for RNA isolation. And it takes quite some time to do all these aliquoting. And in the end, every patient has kind of one of these boxes filled by one patient, basically, and it's all readable with scanners and is a kind of a handy system, but it takes some time, of course, and is something that in the end we hope is going to pay off because it's a resource that is going to last for quite a while, I think. So biobanking is done in 42 patients for now, and we're hoping to get this to get these numbers up in the upcoming months. And we want to prioritize on patients with CKD 1 to 4, so pre-dialysis, of course. Ideally, the patients with even normal kidney function, because in them the identification of early biomarkers would be most interesting, right? So I want to briefly touch upon 3 projects that are ongoing or started within the consortium. One is on MAC1 diagnostics and has been mentioned by Guillaume Dorval earlier. The project is based on the identification of the VN-Typer tool by Hassan and Guillaume and Corinne Antignac earlier. Bernd Popp from our institution was teaming up with them to make the pipeline more accessible, more handy, also for non-bioinformatic persons. So there was an online tool that was created where you can just upload your BAM file and you can have the system come up with a screening. And this is now something that we want to systematically try in cohorts. First of all, in cases that have already been diagnosed to calculate sensitivity and specificity, but then we want to apply it to existing CKD cohorts with existing exome data or panel data. Precondition is, of course, that there is sufficient coverage for the MAC1B type, the MAC1B and TR region. The better the coverage, the more sensitive the tool is, of course. But I think this is a very nice resource, and in the end, it's really meant to be implemented into the diagnostic screening of cases. What we do right now is whatever is it identifies through the VN-Typer 2.0, how we call it, is that everything is going to be confirmed by a second method, either snapshot PCR for DAP-C or PacBio long-read sequencing, which is done in collaboration with Martina Sivna from Prague. I think this tool is notably important in cases of unexplained kidney disease. Just recently, we came up with this position statement from the ERA Genes and Kidney Working Group. Emily is heavily involved here as the chair of this group. We have been designed an algorithm to really raise awareness for unexplained kidney diseases. And of course, this tool screening for MAC1 is something that can be really crucial in identification and resolving unexplained CKD cases. So what we actually proposed here is the term CKDX as a diagnosis, and then to always document whether histology and genetic testing has been done or not done, and of course the methodology, because as long as MAC1 hasn't been investigated with the right methodology, ADTKD MAC1 may not be excluded. Another project that is running in the consortium is the ADTKD-net imaging study. This is led by Stephen Sorbrand from the University of Sheffield. He's an expert on fMRI, and he has been done or designed a protocol that was previously applied in diabetic kidney disease. Has been a large study with 500 individuals with DKD. And the idea was to basically take this protocol and use it in patients with ADTKD UMAT and MAC1, CKD stages 1 to 3, because it implies contrast. And it's meant to be because there's also limitations to the available centers and patients. We will first run a pilot trial with about 50 patients and using controls from the DKD study. And we want to include patients at Charité Berlin and in Dublin, where we have good contacts to our radiologists. And this is going to start in fall 2025. A third project I briefly want to touch up on, I cannot say much about that, but this is something that has been started even before the consortium gathered. But the group of John Sayer with Holly Malibard, and there's others involved, Tony Blair and Olivier Devoist and Eric Ollinger already. They were seeking for ADTKD modifiers and identification of modifiers, first of all, based on the UMOD founder variant in the UK, but then also on patients with UMOD in general. And what they are doing is basically running SNP-array genotypings and also look for polygenic risk score in these populations. By reaching out to the consortium and really being part of the consortium, the numbers of samples now dramatically increased, and they're now assessing more than 1,000 samples, both MAC1 and UMOD, and I think this is going to be a great investigation. So with that, I'm almost at the end of my presentation. So we're planning to enroll 1,000 patients in the registry within the next 2.5 years. We would like you to reach out to us if you have patients. So feel free to connect, and also connect to the nearest ERCREC center, an ERCNet center. This is our email addresses. Paulina is the study coordinator in Berlin. And yeah, we really hope for your motivation, and I think ADTKD patients really deserve this kind of registry to be analyzed in a systematic fashion. So to sum up, European PIs have been most active in the field of ADTKD, but we were always missing a common research platform in Europe, and Wake Forest was kind of the inspiration, because they started this much earlier, and ERCNet provides an established multinational infrastructure to do so. The infrastructure will be long-term and sustainable and is independent of the funding. And the natural histories will hopefully allow us to identify biomarkers, either in serum, urine, genetic or imaging biomarkers. MAC1B and TIPA is one of the projects that have been nicely started during the last 12 months. And this will help in the genetic screening. And we really hope that this is going to be part of the general pipelines of genetic institutes to identify new cases on a broad basis. And the subsidy is ready for enrollment. And we would be happy if you reach out to us and to the partners of the consortium to include your patients. So thank you very much.